All right, today we're going to look at the notes for 10.5 day 1, which you can find on page 22 of your packet. And we're going to actually use the line of best fit like we found yesterday, but we're going to use that line of best fit to make predictions. All right, so yesterday we did the candy grab, where you put your hand into a bowl of candy, tried to grab as many as you could, and sometimes people with bigger hands got more candies than people with smaller hands. Okay, so we're going to use this class set of data below, and we are going to try to find the line of best fit. So it has a lot of numbers in there, so it's going to be a lot to type into our calculators. But if you open up the Desmos calculator like we did yesterday, you can go ahead to the 3 lines up above and scroll until we see statistics and linear regression. And remember, we have to then get rid of all the values that are currently in the table. Sometimes it's easier than others. If it turns blue, it's much easier. Otherwise, you got to just delete the values. So we got to clear out that whole table. Not always the easiest. Go back to that one. But we want to clear out the numbers. There we go. All right. So now that we have an empty table, we've got to type in all this data. We got to be really careful. We can't miss any numbers. So the first handspan value is 18. Next one is 18.5. Then we've got a 19, a 19. We've got a 19.5. Then I've got 2 20s and 2 20.5s. Then I've got a 21, a 21, 22, 2 20.5s, and then I've got 2 23s. So hopefully we typed in all those numbers. If you forgot one, you can always add it to the bottom. You don't have to necessarily go in order, but we do have to make sure that each of the points lines up with the correct Y value. So 18, if you look at our table, has to go with 14. 18.5, whoops, not 6, so be careful there, is 16. And then we got a 19, oh, did it again, 19. And then I've got an 18. Then I've got a 21 and a 19, a 22, a 23, another 22, 24, 27, 28, and then I've got 25, 30, 34, and 35. So before you do anything, it's important to go back and double check those numbers because it's easy to miss a number. So 18 goes with 14, 18, 5, 16, 19, 19, 19, 18, 19.5, 21, 20, 19, 20, 22, 20.5, 23, and then 22, 21, 24, 21, 27, 22, 28. And then on my sheet, I'm looking 25, 22.5, 25, then 30. All right, so I've got all that data typed in correctly. And again, if you had one that was incorrect, you can just delete it and then type in it. Again, you don't have to delete the whole column or the whole row. But the nice thing about Desmos is we just scroll down below and we see our equation right away. So remember, M represents slope down at the bottom under parameters, and then B represents the y-intercept. So what we're going to do is we're just going to write that in the equation. Y is equal to mx plus b. So I'm going to go ahead and slide that over and write it in on my notes packet. But remember, it's not just y, it's y with that little hat, or our predicted y value is 354.54x minus 49.41. All right, so what we're going to look at, and the question it says here is, how much candy can LeBron grab? So if LeBron James came to our classroom, which would be kind of cool, and he put his hand into the candy bin or candy bowl, what would he be able to grab? Okay, so LeBron James has a handspan of 23.5 centimeters. His hand's pretty big. And we want to use that equation up above to figure out how many candies would the equation say he could grab. So we're going to use that equation, y equals. Now, 23 is a handspan, so handspan was x. So we know that x is 23.5. So we're going to go to this equation and we're going to say, hey, it's 3.5 times x. Well, his handspan was 23.5. So we're just going to take that 23.5 and we're going to plug it in for x. And then don't forget, we've got to subtract the 49.41. If you plug that into your calculator for the Y value, we get 33.8 candies, right? Because Y represents how many pieces of candy would he be able to get. So obviously he's not going to grab 33.8, but it's going to be somewhere between 33 and 34 pieces of candy. All right, so now it says when he actually came to this high school, he was able to grab 38. So if you look, we predicted that he could only grab about 34, but in reality, he grabbed 38. Just like yesterday, some of the shorter people were able to grab more candies than some of the taller people. So it's definitely something that's harder to predict. So we're going to go ahead and put that point on the scatter plot. How much did he actually grab? So his hand span was 23.5, and the amount of candies he grabbed was 38. So if you notice on our x-axis, these are going up by 0.5s. So if I were to make this a little bit further, 23.5 would be about right there. And then there's no 36 up there, but if I made this a little larger, 38 would be there. He's actually off the graph. So if I go all the way up, his point would be somewhere about right there. Well, this line that you see right here is our prediction line, right? That's the equation, or that's the graph of this line right here. So if we were to make that line a little bit longer, the question says, was his value higher or lower than what we predicted? Well, the line right here represents what we predicted, and his point was above, so we're going to say that it was higher. Okay, the next question says, hey, by how much higher? Well, he actually grabbed 38, so I'm going to take 38, and we're going to subtract what we thought he grabbed, 33.8. So he was about 4.2 candies higher than what we predicted. All right, now if I was in class today, I would do this right now. I would measure my hand, which I've already done, and my hand is 21.5 centimeters. My hand span is 21.5 centimeters. So we're going to do the exact same thing. I am not LeBron, but how many would I be able to grab? So we're going to take that equation, y hat equals 3.54. My hand span, right, that's my x value, is 21.5. And then subtract the 49.41. If you plug that into your calculator, 3.54 times 21.5 and subtract 49.1, I get 26.7 candies. So again, somewhere between 26 and 27. All right, so after you guys left yesterday, I went ahead and tried this, and I was only able to grab 22. I didn't try it again. I just went with the original grab that I had. So using that data, I know that my hand span is 21.5, and I was only able to grab 22 candies. So let's do the same thing this time, and let's go ahead and put my point on there. So I'm going to go to 21.5, and I'm going to go up to 22, which is about right there. Excuse me. All right, so looking at that point, is that point above or below, higher or lower than what I predicted? Okay, so we can say that what I grabbed was much lower. Okay, and we can say, okay, how much lower was it? Well, again, we predicted that I was going to get 26.7. I only grabbed 22, so it was 4.7 candies lower than what was predicted. All right, so we've got our little chart right here that we need to fill in. Okay, so we know that our y hat equation is y equals mx plus b. That's slope-intercept form. M represents the slope and b is the y-intercept. Okay, and when we do this, we are going to go ahead and substitute a y value in. We're going to substitute a value in for x to get our y value. So when we make a prediction, we're going to plug in an x value to get that predicted y value. Okay, on the right side, it says, how do we find, or what could we say to find the difference between the actual and predicted? So this sentence is a little bit strange because it has the words y context and x value. Well, the thing is, we can do this experiment with a bunch of things. It's not always about hand span and candies. It could be how long did you study and what was your score. It could be how old you are and how much money you make at your job. There's definitely a lot of different things we can compare. So when I say a statement that we can make, it says the actual Y context. Well, what did our Y values represented? Our Y values represent the number of candies grabbed was, and then we're going to use a number. So I'm going to say the actual number of candies grabbed was 4.7, right? That's what the difference was yesterday, or in the last example, lower than predicted for, and what was the X value? What did X value represent? We can say for a hand span of, and mine was 21.5 centimeters. Okay, so we could just make this into a sentence. The actual number of candies grabbed was 4.7 lower than predicted for a hand span of 21.5 centimeters. So this gives you a generic sentence that you can use for anything. We could say the actual salary was $5 an hour lower than predicted for a 16-year-old. So it depends what our Y values and our X values represent. And we're going to do this again within the next problem. So if you look at the next problem, it says, at the end of the semester, a math teacher wonders if student attendance has an impact on final exam scores. Here is a scatter plot that shows the number of days absent and the final exam scores for 25 students. So I'm not going to make you plug in the data to your calculator. If you look down below, I actually came up with that equation for you. So we've got the equation y hat equals negative 3.5x plus 9.09. So we could have plugged the data if I gave it to you in your calculator. But this time I gave you the equation instead. So x represents the number of days absent and y represents your final exam score. So I have it listed right here. X is the number of days absent and y is the final exam score. But you could also look at this just from the table. The x-axis goes horizontally. Number of days absence, the y-axis goes up and down vertically. So that's your final exam score. So we've got our equation right here. And we're going to use that equation just like we did in the last one. And we're going to plug in values for x. So it says, find the predicted final exam score for a student with 7 absences. Well, remember, absences is the x value. So all we're going to do is we're going to go to our y hat equation. And I'm going to say negative 3.5. How many absences? So x is 7. And then plus 90.9. Okay, so plug that into my calculator. And that gives me a predicted final exam score of a 66.4. All right. Now, according to the scatter plot, what did the student with 7 absences actually score? Okay, so we want to go and find where that student was with 7 absences. So I know 7's right here, and if I go straight up, I can see a dot right here. Now to find out what he scored, I want to go horizontally, and it looks like he scored a 75. Now, you can use a ruler. On my iPad, I could have gone straight up here to 7 and snap that line in, and then come across and snap that line in to see that it was a 75. If you would have said a 76, I would have given you credit for it, because if you go straight across, you're right around there. All right, so now it says calculate the difference. So difference means subtraction between the actual and the predicted. So we're going to take the actual score that he got, and we're going to subtract the predicted. Okay, so I'm going to go actual minus predicted. So his actual score was a 75, right? That came from our table. So I'm going to go 75 minus predicted, which was 66.4, right? That's what we predicted up there. And that gives us a score of 8.6. I'm actually going to take this and I'm going to slide it. Oops. I'm going to slide it over a little bit to get that math out of the way so that we can actually write a sentence. Okay, so it says interpret this value. So this is where that box up above comes in handy. Okay, so we're going to look at that box and it says the actual, right? So we're going to start right there and we're going to say the actual. And now it says Y context. So the actual, what was Y? So we're going to say the actual final exam score, because that was our Y context, was 8.6. And now was it below or was it above? Well, we know that they got a 75. We predicted they got a 66. So it was actually 8.6 points higher. Oh, I'm going to go points. points higher than the predicted score of a student, because that's our X content, right? Our X value, a student with 7 absences. Okay, so we're going to actually go ahead and we're going to use that sentence to make a statement, because I don't want to just know 8.6. I want to know what 8.6 is. So it says the actual final exam score was 8.6 points higher than predicted for, and then what was our X value? Our X value was a student, right? The score of a student with 7 absences. All right, and then the last question says, for how many students was the prediction greater than the actual? All right, so this is my prediction line. Okay, and again, the question said for how many students was the prediction bigger than the actual? So here's what I predicted. So I want to look for values underneath. Okay, now if they're touching the line, I'm not going to count them. So if I look here, that person had a lower score, we predicted higher. So 1, 2, 3, 4. I'm not going to count this one. 5, 6, 7. This one's not touching, so 8. This one's not touching, so 9. This one's touching, so I'm not going to count that one. Okay, so 9, and then 10, 11. Okay, so it was below for 11 people. Now, we could get a little bit more specific here and say, hey, what if we're looking here? Well, this one was below, right? So this guy was below, so we actually could count it. Okay, so we could get somewhere between 10 and 11 where the predicted score was higher than what they actually got. So I'm going to actually go 10 to 11 students. If I counted correctly, let me count that one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I missed somebody over here. I zoomed in too far. If I count again, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It was actually 13. So we'll just go ahead with 13, counting that one that fell a little bit below right here. We'll just go with 13 students. If you said 12 students because you didn't count that guy in the line, I would let that one slide as well. But since his point was a little bit below, right, I wouldn't count this guy because he was above. This guy, most of him was above. So we'll go with 12 to 13. I probably would have gone 13. Either one of those would be okay. But we can kind of look at that graph and we can see that most of it was below the line. It was pretty close. So we have a total of 13 students.